Section 2.4, Linear Functions, Graphs, and Slope. We now turn our attention to functions whose graphs are straight lines. Such functions are called linear and can be written in the form f of x equals mx plus b. So before we begin, just to let you know, our m is going to be what's called the slope, and our b value would be our y-intercept. Okay, let's continue with our notes. Definition of a linear function. A linear function f is any function that can be described by f of x equals mx plus b, where m is the slope and b is the y-intercept. The constant b, the y-intercept. The y-intercept of the graph, f of x equals mx plus b, is a point 0, b, or simply b. What makes this point special is that it crosses our y-axis. In a linear function, there's only one such point that will cross your y-axis, and that is your y-intercept. Because it's a point, we always write it as x comma y, but because the value for x is 0, it's always 0 comma b, or 0 comma the number that is your y-intercept. Example, find the y-intercept of the graph of y equals negative 5x plus 4. Well, we could graph it and see where it crosses a y-axis, but based on our definition, we already know where our y-axis falls. Our y-intercept. Our y-intercept is always the point without the x. So in this case, it's a positive 4. Positive 4. So our y-intercept is 4. Or if we want to write as a point, it would be 0 comma 4. Next example. Find the y-intercept of f of x equals 6.3x minus 7.8. Same idea, we look at the number without the x. In this case, it's negative 7.8. So my y-intercept is negative 7.8, or if I want to write it as a point, it would be 0, comma, negative 7.8. The constant slope. We call the change in y the rise, meaning up and down, and the change in x the run, left to right. The ratio rise over run is the same for any 2 points on a line. We call this ratio the slope. The slope describes the slant of a line or the steepness. The slope of a line, if the graph is given, is defined by rise over run or change in y divided by change in x. When we say change, we mean subtraction, the change of something. For example, graph the line containing the points negative 4.3 and 2.9. And I think from here we're trying to find the slope. Okay, so we have a negative 4 and 3, negative 4 up 3, and 2, negative 5. Okay, we plot these points and see the line they make. They also create a slope. A slope is the change of x, change in y divided by the change in x, as we have defined right above. The change of y is called the rise, the bottom is the run. Rise over your run. So here, we want to see our rise, how far up and down we go, and the run, our left to right. So let's take a look at this. Our rise, our up and down values from our graph, go from here to here. our run, our left to right values go from here to here. What makes up our rise and our run? So we rise 1, 2, 3, 4, 5, 6, 7, 8. We went down 8, so I'll write -8. And then our run will go to the right 1, 2, 3, 4, 5, 6. So 6 to the right, and we went 8 down. So that is our slope. That is our change of y over change of x. Now, it would be very tedious to always have to draw a rectangle and find the rise and the run. Plus, what about when we have fractions and decimals? That would be even more work. So luckily, we do have a formula. But before we continue, let's simplify. This fraction, they can both be divided by 2, so it'd be -4 over 3. That is our slope. Luckily, we have a slope formula so that we don't have to graph it and count our rise and our run each time. Our slope of our formula is defined by y2 minus y1 divided by x2 minus x1. Those little subscripts of 1 and 2 refer to your point. So if I have a point 1 with x and y, and I have a point 2 with x and y, then those subscripts let me know that that 1 tells me that is from point 1, and that 2 lets me know that those are the values from my point 2. Now, it doesn't matter which one is point 1 or which one's point 2, as long as you're consistent. You keep the labelings that match the point. We must remember to subtract the x coordinates in the same order we subtract the y coordinates. That's what I meant by being consistent. Okay, example. Graph the line containing the points -4, 3, and 2, 5. That's just what we did. Let me change the instructions to just find the slope. Okay, we have a formula. We have m is equal to y2 minus y1 over x2 divided by x1. Let's label our values. I have to label them because I know my eyes will trick me and I will make a mistake along the way. So I will label my first one x1, y1, my second one x2, y2, so that I know exactly where my points are. Okay, let's find the value. y2 is -5 minus y1, we said is 3, divided by x2, which is 2, minus x1, -4. So let's say our answers. 5 minus 3, that gives us -8. And 2 minus -4, that gives us 6. So our answer is -4 over 3. Just like we saw before when we went through the trouble of graphing it. Definition of slope-intercept equation. This equation y equals mx plus b is called the slope-intercept equation. The slope is m and the y-intercept is 0, b. Example, find the slope and the y-intercept of y equals 5x minus 4. Okay, just as our equation says it, the m, the number next to the x, is our slope, and b, the number that doesn't have an x, is our y-intercept. So from here, we can conclude that our m is 5, our m is 5, our slope, and my y-intercept, my b, is -4. So that we can clearly state that our slope is m is equal to 5, and my y-intercept is 0, -4. Find the slope and the y-intercept. Now our formula is set up so that I always have y solved. I always have y by itself. So let's go ahead and solve for y. Solve for y. All right, so we have 2x plus 3y is equal to 8. Let's go ahead and solve for y. Okay, so let's get y by itself. Let's go ahead and move the 2x minus 2x. And we're left with 3y is equal to, let's write the x first. So I have a negative 2x plus 8. All right, let's go ahead and divide by 3. 3 divided by 3 is 1. So we're left with y is equal to, and then this 3 is dividing each of the terms in our numerator. So I have negative 2 over 3x plus 8 over 3. So then now I can clearly highlight which one is my slope and which one is my y-intercept. And now I can answer my question. My slope is negative 2 over 3, and my y-intercept is the point 0, 8 over 3. Moving forward, applications. Slope can also be considered as a rate of change. Example, the total spent by U.S. Cancer Center on advertising increased by 54 million in 2005 to 173 million in 2014. 20 of the 890 cancer centers who spent 173 million in 2014 account for 86 of the total amount spent. Find the rate of change in the amount spent on advertising cancer centers with respect to time and years. All right, when it's asking for the rate of change, it's just asking for the slope. So we want to find the slope of the amount of money spent by these cancer centers. Okay, we have a picture which really helps in order to create this correspondence to the year and the amount spent. So think of these as points. We have these points as 2014 and 173 million, and 2005 and 54 million. So think of these as coordinate points. So if we want to find the slope, this would be my x1, y1, and my x2, y2. So we want to find the rate of change, which is like your slope, which by our formula is y2 minus y1 divided by x2 minus x1. Now that we labeled our points, let's just find the slope. They're really big numbers, have your calculator handy. So our y2 is 173 million minus 54 million divided by 2014 minus 2005. All right, once we subtract, we'll get 119 million over 9 years. So per year, what is our rate? It would be about 17,222,222 per year. That is the amount spent on advertising by cancer centers is increased at a rate of 13,222,222. And this is how you can see slope in an application type of problem. All right, that's it for this section. Now for this section, we discuss specific pieces of a graph, such as your slope and your y-intercept. Thank you.